Okay, so do you guys agree that this is a little confusing?
My calculator's broken.
Your calculator's broken, it's brand new. Thank you for
Press
sharing.
the on button.
Yeah, all right, can I have it so I can take a look into the, I'll take it over. All right, guys, so we're silent, right? I'm gonna give you guys a little bit of a hinty hint to start this. It's giving you some information about 2 different movie theaters and which one would be the better choice for these friends to go based on the price of the tickets and the price of the popcorn. Now, let me ask you a question. If I flipped these prices and the popcorn for theater A was $6.75 and the popcorn for theater B was actually $5.75, do you think the question would be a lot easier to solve? Tell me why it'd be easier to solve. Yeah. Yeah. Exactly. If both the movie price for theater B and the popcorn price, if it was switched, then the ticket price and the popcorn would be cheaper, so you wouldn't even have to do any real math. You would just be like, well, just go to theater B because it's so much cheaper. So in this case, the ticket price in theater A is more expensive, but the popcorn is cheaper. So we're gonna have to try to figure things out, and yes? You're on the right track. What we need to consider is that there's some information in the question that we need. This is the most annoying part of the information. They don't tell you how many friends. This marker's done. It's the second time today I've done that, okay? So this information is a little bit annoying because they don't tell you how many friends. It'd be a lot easier, let's try to keep all noises to a minimum. Okay. So it says some friends. It doesn't say how many friends are going. If they tell us how many friends are going, we would be able to figure it out pretty easily and just do some calculations. But they only tell us some friends are going, so it means more than one, right? Maybe 2, maybe 3, maybe 4, maybe 5, who knows? They want to see a movie, and they're looking at 2 different theaters. They plan to share 3 tubs of popcorn, so that's going to be really, really important information. So if it's just 2 friends going to the movie, how many tubs of popcorn are they sharing? 3. If 3 friends are going to the movie, how many popcorns are they sharing? 3. If 18 friends are going to the movie, how many tubs of popcorn are they sharing? 3. So 3 is a constant. That's not going to change. So we don't know how many friends are going then, but we do know that no matter how many friends, they're going to split up 3 tubs of popcorn. Now, in order to really understand what's going on here, let's map out a table that helps us organize the information. I'm going to put theater A over here.
Shut up.
And I'll put theater B over here.
Rip that. I'm so sorry.
So here is going to be our table. First, I'm going to have a category for the number of friends.
Having dramatic
Then, because it doesn't tell us how many friends, so I'm going to do a couple of different scenarios. Then I'm going to do a category for the ticket prices. And does the ticket price, does how much they spend on tickets, is that going to change depending on how many friends go? Right, but the total that they're going to spend on the popcorn is not going to change. So ticket prices and then popcorn. So, for example, we can't start with 1 friend because it says some friends, so we have to start with 2, right? The ticket price for theater A is $14.50. But are they gonna spend $14.50 or are they gonna spend more than that? How much more? 2 times more, right? Because you need 2 tickets if 2 friends are going. Now, the popcorn is, theater A is $5.75. And how many tubs of popcorn are they getting? 3. We're gonna continue this a few more times. It doesn't tell us how many, but let's just start with 2, 3, and 4 and fill in the information. What would this look like? 3 times $14.50. What would this look like? 4 times $14.50. What would this look like?
3 times.
Yep. What would this look like? Good. This is all going to stay the same. All right. Let's move over here to theater B. You don't have to do anything with that yet. And let's make the same table. Friends, tickets, popcorn, 2 friends, 3 friends, 4 friends. I want you to tell me, what would this look like? Theater B, 2 times 13.
I meant
3 times 13, good. And then 4 times 13. What about popcorn? 3 times $6.75. Because the popcorn's more expensive at theater B, but the tickets are cheaper. Okay. Good. We're gonna keep going. Same thing, no matter how many friends go, right? Okay. Now, the only way we're really going to be able to compare is to find the totals, right? So I'm gonna make another column.
another one.
Yep. And this is where your calculator is gonna come in. And if you guys wanna have your calculators out,
Oh, you didn't get it.
what would the total of 2 friends at theater A be?
49. What?
So 2 times $14.50. What is that? 29. Plus 3 times $5.75. What is it? What is it? Say loud. 17.25. Add those together. And what do we get? You can just punch into your calculator, yeah.
It's 46.25.
Good. 46.25 is the total for this. If you don't have a calculator, where are all my calculators going?
We ran out.
How did we run out of calculators?
They ran off.
Somebody stole it.
Who needs one?
Me. Right here.
You
right
guys
here.
all need one? Okay. You're gonna have to share your calculators for now, and I'll open up some more in a little bit, okay? All right, let's keep going. So far we only have one total. We have nothing to compare it to, so that's, can't really do anything.
Yeah.
Okay? First of all, let's take a break and look at our questions, okay? Which we probably should have done from the beginning, but I know you guys spent some time reading it. Which movie theater should the friends choose? Obviously, they're gonna wanna choose the cheaper one, right? What situation would the total cost at each theater be exactly the same? And that's gonna be the key question for this lesson. What situation would the total cost of each theater be exactly the same? So, once we find the totals of everything, if we find a match, then that will be our situation where they would cost the same. All right. So, did anybody do this one yet? 3 times 14.50? Come on, I'm relying on you guys.
I don't have a calculator.
60.75 plus?
No, that's the.
Oh, the total? Okay. Thank you. So 60.75. If you guys are working this out, just give it to me. 60.75 for that. What's this? Shout it out. You have to do 4 times 1450 plus 3 times 575, but you have to do those first and then add them together. Anybody? Do you need me to do it? I just gave away my calculator.
Needed one.
Shouldn't have done that.
What's 4 times, you guys all have calculators, what's 4 times 1450? Plug it in.
4 times, 5 times.
So the whole thing's 58?
No, 4
What?
times 4 times 4.
Okay, 58 plus, okay, so 75.75, okay, thank you, we're working quick. 25? All right, so does it make sense that the price is going higher and higher? Even though the popcorn price total isn't changing, the ticket prices, every time you add a ticket, it's going higher and higher, okay? Let's go over here. What is my total for theater B for 2 friends? Come on, get on those calculators, people.
For tickets?
Great.
Bro, tell me now.
It's 46.
46.25? Okay. Next.
I'm too slow to answer all this stuff.
It's okay. 59.25.
Wow. Big pace, guys.
72.25. Now let's start looking at the difference between theater A and theater B's prices. What is the first thing you notice when you compare? Yes.
That, if they both went, if 2 friends went, they both would be the same.
Exactly. So that answers our part B question, right? If 2 friends go to the theater, if only 2 friends going, they're gonna end up spending $46.25 at theater B or $46.25 at theater A. So how do they know which one to choose? Probably which one's closer or which one has more comfy seats. Like Cinema 6, if we were playing Cinema 6, they are reclined, it's really good cozy.
Never.
I watched the Mario movie there.
Yeah, good prices and really good seats. So, stay facing forward, please, okay? So, obviously, it doesn't matter which one they're gonna go to, they can choose it based on which movie theater they like better. But, if you look at the situation, with 3 friends or 4 friends, which one should they choose?
B.
B. Because it's gonna be cheaper, okay? Even though the popcorn's more expensive, as you add more people and more people, it's going to just stay cheaper than theater A. So if it were 5 friends, 6 friends, 7 friends, comparing, it would still be cheaper. Because at this point, it's just gonna get cheaper and cheaper compared to theater A because the ticket prices are cheaper. Do you guys understand? Okay, we're gonna move on to. Okay. I'm gonna take a second, and then we're gonna move on. And yes, I'm using my son's water bottle today because he forgot it before he went on the bus. And I was like, oh no, he forgot his water bottle. And then I realized that I forgot my water bottle at home, so I kind of lucked out. And also it looks really cool, galaxy. Alright.
Leave me alone.
Yes.
Please don't use
I would
that
put
vowel.
theater B, yeah. I would say, like, if I were to answer that question in words, I would say, if more than 2 friends are going, I would choose theater B.
I think this was a
This is like super crooked.
That was a fun one.
Yeah.
Regal is way better than Cinema 6 though.
No, it's not.
Just because
It's
Cinema
so
6
way
has comfortable
more
seats does not mean anything.
It's cheaper too.
Okay, and I'd rather have a good movie experience.
I mean, if you're not sitting next to us.
Yeah, I don't want to sit next to guys. We all know how that.
All right, guys.
Crawling on the ground.
I'll be eating my tops.
Like our drinks.
No, me and Jenny were pretty quiet.
See, what would you do?
We're always quiet though. Until like the end.
So, the method that we use to solve this problem, and you don't have to answer this question in your notes. Excuse me. We used the table method and we compared prices, we compared the totals. There is an equation that you can set up to solve this, but we didn't do it yet because we're gonna actually learn about those equations in this lesson. So I would, if I were to answer C, I would say I did the table method and it worked just fine. Because we didn't explore the setting up of equations method yet. All right.
I'm trying to learn.
The chatting and noise that is coming from this section of the room needs to stop. If I have to address it again, it's not gonna go well. Okay? Thank you. Just a yes, ma'am, real quick is great. Yes, thank you. All right. How do you create equations with a variable on both sides and use them to solve problems? Notice in the do now problem that we just had, we had an unknown for both theorem A and theorem B. And we had to compare them. But we didn't set up an equation yet. We're gonna learn how to do that here. First, we're gonna start with equations that are already set up for us. So this is part one of the lesson. And real quick, let me just go over something. If you look at the homework board, on the left, we see that we're learning part one of today's lesson, okay? We're gonna get through some of the examples today. I put the homework as due on Friday. I know, yes, today's Monday, it's due on Friday. We have hurricane days tomorrow and Wednesday. Thursday, I do not need a reaction. Thursday, we're gonna finish this lesson and the homework will be due on Friday. But you can start the homework tonight and work on it before we finish the lesson because we're gonna learn a lot about some of the homework questions. So you'll be able to answer like probably 80% of the homework questions before I finish the lesson. So if you wanna get some of the homework done before Thursday, then you can do that, yeah. I believe, I can't remember if it's a geometry algebra, I think we're around 17. Actually, I think that's geometry. I think for you guys it's like 25, but that's because you have plenty of time. So it might be 25. I went through them and I made sure none of them were like beyond difficult, okay? So, notice how this equation has x terms on both sides. We haven't done that yet, right? We've had enough trouble just trying to solve equations with x on one side, right? So, it's okay. This is not much different, and we're gonna use something very similar to combining like terms to help solve this, okay? And here's the thing about the way the book solves this. Wait, is this for this one or the next one? It's the next one. Okay, we're gonna solve this, but I'm gonna do it over here because the book doesn't really tell you all the steps, and I really want to go through every single step the way you solve this, okay? So I'm gonna write it over here. I'm gonna write 3x minus 10 plus 4x equals -2 times x minus 4 plus 9. Can everybody see that? Mm-hmm. Okay. Go ahead and write that down. There's a there you just kind of shift your head a little bit.
Shut up.
Did everybody get that down? No. Push your chair all the way forward. No comments? Okay? Yes, ma'am. Now, there are a couple of things that might kind of jump out at you as to how you want to start simplifying this. We can't really solve anything yet, right? It's gonna take a lot of steps to solve it, but we can start by simplifying, making things simpler. We want to say, it says, what is the value of x? We want to find the value of x, but before we solve, we need to simplify. Yes? Yes, we can combine like terms. I gotta get my separate color because you guys know that when I combine like terms, I always circle. Pardonnez-moi, s'il vous plaît. Can you guys scoot a little bit so I can? So Anna, this is gonna be on YouTube, okay? So make sure you watch the rest of it. You've got a lot of time during that hurricane, okay? Make sure your computer's sharp so you can watch it. Okay, so the focus is up here. The focus is up here, not about the early dismissal, okay? So I'm going to circle my terms with their signs that I want to combine.
Tells me
3x plus 4x equals 7x. Good. Then I'm just going to very gently cross these out, only with a single line so I can still see them, but I know that they're no longer involved because I combined them. Then I have my minus 10. It doesn't matter if you put the minus 10 over here plus 7x or if you put the minus 10 over here. Same thing. Then over here, we can also simplify by using our, very good, our distributive property. So you know, front office. Can you lock the door before you close it, please? Okay. Anyway, when I distribute, another good idea when you're distributing is circle your terms with their signs. So when you distribute, now keep in mind we're multiplying here. We're not adding like when we combine like terms. So we still are multiplying, but the signs are so important when we multiply too, right? Right? Yes.
Right.
So if we're multiplying a negative 2 times x, what do we get?
Negative 2x.
When we're multiplying a negative 2 times negative 4, what do we get? Positive 8, and then we still have positive 9, okay? Now, what is something I can do next? Which ones? 8 and 9, good. So now we have created another set of like terms. I've got my plus 8 and my plus 9, and I'm going to combine those. So I'll still have this being the same because I can't combine the 7x and the negative 10 because they are not like terms. So I have my negative 2x plus 17. So it's starting to get simpler, right? But I still have x on both sides of the equation. We're gonna kind of combine the idea, we're gonna combine the ideas of combining like terms, but also making sure to remember that we have to do it algebraically because we're going across the equal sign, okay? What's that?
So that whenever you do the one side, you do the other.
Exactly. So I do want to bring my x terms together because they can join together, but I can't add them together because if I add them together, there's nowhere for them to belong. If I solve algebraically, I can put them together, and there are two ways to put these x terms together. You can either add 7x to both sides. I'm sorry, not add 7x. You can subtract 7x from both sides because this is positive, right? Or you can do what? Add 2x to both sides. Tell me why my preference might be to do it this way. Yes, because it's easier. And if I do it this way, then I don't have to deal with negatives. If I subtract 7x, I'm gonna have a negative 2x and a negative 7x, I'm gonna have a negative 9. And I like to avoid negatives if I can. When you have a choice, choose the easier way. Okay, so when I combine these, I get 9x, and that's done, minus 10 equals 17. Now here, is a problem that we spent a lot of time working on in lesson 1, okay? This was lesson 2. Now we've got it down to a lesson 1 problem. Emily,
So you're gonna add 10 to
very good.
and then do the same thing.
Yep, add 10 to both sides. 9x equals 27. And Lathan, take it from there.
3.
Yeah, but tell me how to do it. Yeah, divide by 9 on both sides, cancel, and x equals 3. Now, do you guys agree that y'all have come a long way since day 1 when we started lesson 1? And lesson 1 was super scary, right? And now you guys are not just solving for x, but now we're solving for x when x is on 2 sides, when we have to use this distributive property, when we're combining like terms. I mean, you guys are killing it right now, right? Give yourself a little pat on the back without any talking. Good. Okay. The book solves it in a totally fine way. It's just a little less detailed. I like to show every step. Now you know they're gonna give you one with a fraction, right? Just to mess with you. And here's a little thing about what the book does here. When we have a fraction involved, and the fraction is being multiplied by something in parentheses, we have a couple of different ways that we can go about this. The book chose to do, well, they chose to, first they took care of some terms here, we'll get to that in a second. But then they chose to get rid of the half by multiplying by 2 on both sides. I'm actually not gonna do that one right now. I wanna start with the method that I think is a little bit easier, that makes a little more sense, okay? So the first thing I'm gonna do is I'm gonna rewrite my problem, and I want you guys to be writing if I'm writing, okay? Now, even though the book didn't solve it this way, I actually think using the distributive property is a simpler way to solve it. I'll show you my way, and then I'll also show you how the book did it. There might be some equations in the future where it would make sense to use that method, but I'm gonna show you this method also. So if we distribute our 1/2, what does that give us? What's 1/2 times n? 1/2 n. 1/2 times -4, I'll show that up here. 1/2 times -4 equals what? -2. -2. So I have 1/2 n minus 2. Remember how our negatives also act as minus signs, and our minus signs also act as negative signs, right?
Yeah.
So we still have our -7 over here. Am I supposed to distribute the half to the -7? No, because it's not being multiplied times a half. So then we have -7, and I know you're gonna wanna combine those, that's okay. Just hold off for a second. We have 1/2 n minus 2 minus 7. And then it's gonna write the rest over here, -2n plus 6. So let's go ahead and combine our terms here, because I'm sure they're already jumping out at you. Okay, so now we have 1/2 times n. Then what? We're combining a -2 and a -7, so we have -9. Yep, -9 or -9 equals -2n plus 6. Much simpler now. I know we still have a fraction, don't worry, that's actually not gonna be a big deal.
We just make it a decimal.
Oh, you absolutely could if you wanted to.
Every time I have fractions, I just do the decimal.
Yeah, I mean, yes, but if you have something like 2/3, you're gonna wanna keep it a fraction to keep things accurate as you move forward. But in this case, totally you could make it a 0.5. Yeah, but for now, I just wanna leave it as a fraction so you can see how we deal with this, okay? Now, what is something that you're noticing that will be like the easiest thing to combine across the equal sign?
Plus 9.
Yeah, the -9 and the +6. We have two choices. We can add 9 to both sides or subtract 6 from both sides, which was easier.
Plus 9.
Adding 9 to both sides, and that's just a choice. (1/2 times n equals -2n plus 15. We are getting so close to making this look like a lesson 1 equation, okay? Now, what can I do?
2n.
Add 2.
Yeah, that's gonna be another way to make it easier. Also, we do wanna keep our variable on one side of the equal sign, so if I were to subtract 1/2 n, it's not that it would be wrong, it's that that would become 0, and then you would have to move the 15 over to the other side. It would cause an extra step. If that sounds confusing to you, just forget I said anything. We don't need to worry about that right now. Forget about it, okay? So we have plus 2n plus 2n. Now it's okay, I've got a whole number and a fraction, but they're super easy to add together, right? What's 2 plus 1/2? 2.5, yeah, you're still thinking decimal, that's fine. Or 2.5, that's okay. So we have 2.5 n equals 15. Now, when you have a mixed number,
Add 2.
yeah, we're gonna automatically wanna change it into an improper because
Fine.
that's how we like to work with our fractions, okay? So it'd be 5/2, and I'm erasing since I don't have a lot of room left, but you guys can just write it over if you don't wanna erase it. What is the shortcut we learned about if a variable is being multiplied times a fraction? Yes, very good, especially for being out for a while. Very good. Now, can somebody explain to me why multiplying times the reciprocal is an okay shortcut to do? What's that? It cancels it out, right? Can anybody explain to me why that is essentially the same thing as divide? Because n is being multiplied times 5/2. So if we use our algebra and we say, well, we have to do the opposite, we would say, well, then divide this by 5/2, right?
Don't we just multiply by 2?
Yes, and that's what, yeah, she got it, and I just want to explain to everybody why that's okay, because we only talked about it a few times.
Why can't you just do 2.5 divided by 15?
Not again.
Well, it would be 15 divided by 2.5, but you could, I'm keeping it in fraction form because I want you guys to be okay with fractions, because this is an example. You know that on your homework and everything, they're gonna give you like 2/3 or 5/9, and it's not gonna be an easy decimal to go into, okay? So, all I wanna remind you guys of is why it's okay to do this on them all. Probably the last time I'll do it, okay? So if I have 5/2 times n, and I wanna divide by 5/2 and cancel it out, isn't 5/2 divided by itself keep, change, flip? So when we're dividing a fraction by itself, we're really multiplying it times the flip, the reciprocal.
But it's still gonna be a 1.
Exactly, it will cancel out to 1. That's what we want. That's what we want.
Or divided by this?
No, when you're dividing a fraction by itself, what you're really doing is multiplying it times the
So
reciprocal.
we're doing multiplying.
Yes,
Okay, so
that's what we're doing. I just wanted to, I wanted to remind everybody why that's okay.
That's what we want.
So we're multiplying it times 2/5. Oh, no, 2/5. And that cancels. And then we multiply the other side times the same thing by 2 over 5. And you can either cancel, or you can multiply 15 times 2 is 30. 30 over 5 is
I'm sorry, 6.
6. And if you cancel, you would cancel the 15, you would cross out the 15, put a 3, cross out the 5, put a 1, 3 times 2 is 6. So any way you slice it, you get n equals 6, right?
Marianne, can you move your head, please? I can't see. Thank you.
Okay. Totally understand it? I just want to take a minute to, you have to wait till she comes back, okay? I just want to take a minute to go over the way the book did it, and they got the same answer, and there's nothing wrong with it. And there might be a problem coming up in the future where this method is going to be the easier one, okay? Like when things get more complicated. So let's explore the way the book did it also, okay? Can I erase this? You good? All my beautiful work erased.
I forgot that. I'm sorry, I'm not even finished.
Okay. All right, so what they did here, I'm just gonna do it because it's easier if I show all the steps. N minus 4 minus 7 equals, I want you guys to write this down as well. I want you guys to know both methods, okay? Both methods are totally fine. It's just gonna depend on the type of problem that you get, which method you're gonna wanna choose. And it's always nice to have choices and you can use your preferred method. Aiden, do you need to? Go ahead. Alrighty. So, I want you guys to be able to like read what the book did. Notice what they did going from here to here. What did they do?
They canceled that all.
They added.
Yep, they added 7 to both sides. But isn't it kind of annoying that they don't show that? Sorry, it just annoys me. I like to show everything. Okay, so they added 7 to both sides, and so the only thing that changed so far, what are we saying? Facts?
Yeah.
Oh, like that's a fact?
Yeah.
Oh, okay, great. I thought you were saying X, and I was like, we're solving for N. Okay, 1/2 times n minus 4 equals negative 2n plus 13. Now, what is the next thing that the book decided to do?
Something.
Something is right.
Multiply each side by 2 to eliminate the fraction.
Yes, that's what they did. And we did something similar in lesson 1, right?
We did.
So what they decided to do, they said, I don't want to distribute. And that's fine.
What would they get for two?
So the good thing is, you can do anything you want. I can multiply this times 40 if I wanted to, as long as I multiply this times 40.
Oh, okay.
Right? So technically, the reason they chose the 2 is because they knew that if they multiply this times 2, then it will cancel out the 1/2. And then they just had to do the same thing to the other side. But this is what I don't like about it. You have to do the same thing to the whole thing on the other side. Facts, okay? And then, I'm just gonna make room over here. So we do have our n minus 4 in a nice, neat part over here. But then, you have to distribute the 2 to this, and the 2 to this, and it's just a little excessive for me, but it's okay, we'll keep going. So the 2 times negative 2n is negative 4n. The 2 times positive 13 is positive 26. Now what should we do? We have 2 options.
Yeah, just add one of those sides.
Yeah, we can take care of the numbers first. Add 4 to both sides. It doesn't matter if you take care of the various variables first or the numbers. So we have n equals negative 4n plus 30.
Then we were
all the candy.
Yep. Add 4n to both sides. What do I want to make show up that's hiding? Yes, this n has the coefficient 1. It's invisible, but we can make it appear or disappear like little magicians. Okay, so I'm going to add these together and get 5n equals 30. And then divide by 5 on both sides, and I get n equals 6. Same answer, little bit of a different process. Do you guys have a preference which one you like better on this one? First one? Yeah, I mean, I think they're both totally fine. It's really a matter of preference, especially depending on the type of equation you have. For example, if this fraction was something like 2/3, I don't think I would want to multiply by 3/2 to cancel it out and then multiply this whole thing by 3/2. That would be a pain.
Facts.
So, right?
Facts.
Okay, are we done with this, or are we still talking?
Dumb.
Okay.
I feel like, well, we're not multiplying the other side by 2/3, we're just multiplying it.
We are, we have to, if we were, like, if I were to flip that,
And this one, when we did that, we didn't multiply it by 2/1 on the other side. Oh, wait.
yeah, we did, look, yeah, exactly. All right. You guys are doing really, really well. With what we learned today, you'll be able to do like 80% of your homework. I would love you guys to try to solve one of these on your own. I'll let you choose which one you want to solve. You can choose A or B. Yeah, I would say try A. That would be like my preference. So for A, I would go ahead and distribute. Because you can't combine any of the terms or move them across the equal sign until you get rid of those parentheses. It is, when I write my z's as variables, I always put a little, yeah, otherwise they can sometimes look like 2s. All right, keep working, see if you can get it.